Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and discuss how to actually distribute our C++ source code that we create for our Java project. So basically, unlike Java, which is platform independent, and we can distribute our binary as a jar file, as a packaged jar file. Typically, we cannot just distribute the C++ compiled code or object files because object files are machine dependent or platform dependent. And when we say platform, it means a combination of the CPU architecture and then the operating system. So if you look at the compilers that we typically use, GCC, G++, they support makefile systems, right? So basically, in order to build the binary, for example, a dynamic library or an executable out of a C++ project, we have to use some sort of build system. And G++ and GCC, basically the GNU compilers, they support make, which is one of the nice build systems, right? And then why do we distribute the source file of the C++ project? Because others can use it to build binaries for their own platform that is not provided by you. So clearly, if we write a C++ project, we can compile it for different platforms, Mac, Windows, 32-bit, 64-bit, and provide the pre-built binaries, right? But maybe there's some other platform that we haven't considered, we haven't compiled for it, so then the users can just download our source code and compile it for their own platform. So they have their own compiler specific to that platform, and then they compile the project and they create the binaries or executables or dynamic libraries. Now Eclipse CDT has two modes of build operation. One of them is internal builder and the other one is GNU Builder. Obviously, GNU Builder creates the make targets because the GCC and G++, the GNU compilers work with the make targets, make build system. And then the internal builder basically doesn't create them. It just invokes the GCC and it automatically tells the compiler which files to compile and eventually which artifact to generate. Is it a dynamic library? Is it an executable? All platforms can support make when we install GCC, GNU compiler. On Windows, we can use .bat file in the root directory of mingw or mingw-windows 64 to run a command prompt, a command line window that the path to the bin folder of the mingw or mingw-win64 is automatically added to the path of the system environment variable. So make sure you set your project builder to GNU Builder in Eclipse CDT so that it automatically generates the make files. It can create make targets, and then the usage is typically in the command line we go into the directory that includes a particular make file. So we have to include that basically make file. So there is a file called make file. And then we go into that directory in our C++ project, and then we say make, so that the command is make, and then it has some targets, target name. And the common targets are, if we say make and then no target, it doesn't do anything, right? So if we don't specify any target for the make command, it will compile all the CPP files and create the .object files. But that's it. It doesn't create any artifact. It's just compilation. So this is just compilation. If you specify a particular target like make all or make DLR or make dynamic library or whatever, it actually creates that artifact. So it starts with compilation and it stops right at that specific target, like generating an artifact, a dynamic library, and executable. But there is another useful command, all. When we say make all, it just goes through all the targets in the make file. We'll execute all of the build targets in the make file. So let's head to Eclipse and try to look at how we can actually work with this make file system. So in Eclipse, if you recall, we had this Maven native Java project, and then we created a Maven native _C that implemented one of the classes, the native method inside this project, and then we created this dynamic library lib maven _native_c.dylib. And then we compile this and put the dynamic library at the top of basically at the top of the resources folder, right? So now let's look at this C project. So I'm already in the C++ perspective. And then if I built it in the debug mode, right? So when we build the project, it has two options, debug and release. And then if you look at this make file, so this is in the debug folder. If I build it in the release mode, it creates another folder called release, and then it puts all the generated artifacts, make files inside that folder, right? So debug mode and the release mode in Eclipse CDT, they get their own make file and all their own specific files, right? So if you look at the debug, what happens here is that we have this src, and then it has our object file and this d file or directory file or dependency. So this d is the dependency, and it tells the which dependencies are to be included. And you see we have JNI MD and JNI H. These are the JDK folders, and then the JNI header. So it tells the compiler for each CPP file that is supposed to be translated into an object file, what are the dependencies. All right. And then if you look at this make file, this is where interesting stuff happens. First, we have this rm, which is defined as this command remove -recursive f. So this recursively removes all the files. And obviously you can assume that basically you can guess that there is a target for make, which is clean, very similar to the clean goal in the Maven. For Java, we have this clean target for the make, and then it just uses this rm, this remove that is defined in this command, and then it adds all the basically CPP, C++ files that are supposed to be removed. So it removes everything, it cleans it, right? And it also cleans the final artifact, which is the dynamic library. So if I just another thing that in this outline view for the make file, we have a very nice outline view of what's going on. And you see we're including some stuff, make file, and then include source.mk. So it includes some directory that tells which sources are to be included, right? Source direct, what is the subdirectories, what is the src, which type of files are supposed to be compiled. And again, file for C++ doesn't have any meaning. It's just we tell the compiler which files to treat as source file or translation units. For example, C++, srcs, and if we add Fortran compiler to our tool chain, if we looked at this in one of the previous lectures, then it also adds all the Fortrans as Fortran files as translation units. And then we have this global variable rm, which is defined as this command remove recursively, and then we have these targets. So these shapes, green dots, these are like a dart thing, and they are targets, build targets or make targets. We have all, we have lib maven _native_c. This is the target. If we invoke it, it compiles and goes all the way until it creates the dynamic library. And another target is clean, which removes everything, right? There's also this build target for our maven native C, and we can manually add build targets. If we don't want to manually edit the text file, we can just add the build target, new build target here. But I guess for a standard C++ project, eventually we want to create an executable or a dynamic library. Therefore, basically it automatically gets generated by the Eclipse CDT. So one of the things that I can do here, and I want to show you, if we basically give this we put this project, the CPP files, including this debug folder that has all these make files. So basically when we distribute our C++ code, we have to also distribute some sort of build system, which in this case is a make file build system, to the user, so that the users, when they download the C code, they also download this make file, and then they run it with their compiler, the make command, and the compiler now knows how to actually build the C project and create the final artifact. So let's say, and the problem here is that obviously creating a dynamic library is platform dependent, because the extension is different, the naming conventions are different. Maybe there are different things. For example, here in the makefile it says invoking Mac OS X C++ linker. So if I just give this to someone else and they try to run this makefile and Windows platform, obviously this is not a correct thing, right? It shouldn't say Mac OS. So it's more or less platform dependent. But if somebody else has a Mac OS and downloads this C++ project, they can easily build it. So if I copy this project, I have already created a folder called test make, and let's paste it here. Let's say somebody has already downloaded this, and let's say I did not compile this code, right? This not project. Basically my debug folder is empty, i.e. there is no artifact here. So if I open a terminal at this folder, let's also maybe increase the font size a little bit. All right, let's clear this. If I do ls and then go to debug folder and do another list, you see this is makefile. So we download, let's say we download the C++ project and go into the folder that has this makefile command, because that's the configuration. All right, and then let's say I did not the developer that created this C file, this C++ project, didn't include any artifact, and I want to actually build this project and make the artifact the dynamic library. So let's say in order to do that, let's say I run the make clean in the clean target of the make, which is specified in the makefile, and it just recursively goes into the folders from the top one, which is the debug where the makefile is, and removes all the files, right? So it runs the rm remove recursively all the object file, directory files, and also the artifact. So let's say we just downloaded this C++ project in this state. It has the cpp files, the header files, and the makefile build system, but it doesn't have any artifact, any compilation, right? So how do we do this? Obviously, if you look at the makefile, it specifies a few targets, right? So it had old lib maven underscore native underscore c dilib and clean, and we just executed the clean. And now let's say I want to create a dynamic library. So if I just run make with no target, it just invokes the compiler and does the compilation. So you see, we see the object file and the dependency file, but there is and the artifact was also generated. So I guess this is a good news that it also generates the artifact. But then we can also, let's run make clean again, and let's clear, and then I can say make all, and it does the same thing, creates the object files, compiles all the compilation units, CPPs, and then the object files are created, and then the dynamic library is eventually created. And then there is another target in our makefile, which is specifically lib maven underscore native underscore c dot dilib. So I can also invoke that. So let's run make clean again, and then say make lib maven underscore native underscore c dot dilib. This is another target in our makefile. So if we do that, we get the same thing. Basically the dynamic library is generated. But again, the problem with make is that it's a little bit platform in specific, because this dilib obviously is not the extension for dynamic library in Windows. So it won't immediately work on Windows. And the other thing is that this project has dependencies, right? And this JNI edge and JNI machine dependent edge, these are specific paths that we specified. So if you try to compile this in Windows, it's not going to work, because the path to this JNI edge is based on the absolute path, which is not good. Obviously the header files in the project are relative, so if you can, try to always include relative paths, because then it's more portable to other platforms. But in this case, the JDK is we can't really declare it as a basically relative path. It's just wherever we install the JDK on our operating system. So let's say make clean again. All right, And then so this is how someone else can quickly build this on their Mac OS. But what about Windows? So let's go to Windows, and I have Windows here. So let's quickly go to bring up that basically this folder. So desktop, test make, and then this is my Maven underscore native underscore C. I'm going to copy and paste it. And then what I'm going to do, so let's try to see if we can do the same thing that we just did with basically with in macOS. So I'm going to open up a CMD here, command prompt, and let's see if we can. We already have G++ here, and let's say G++ hyphen version. This is the G plus or GCC hyphen version, GCC hyphen V, and this is from Cygwin. Let's say I want to compile with MinGW, so I'm going to open up a Windows, a folder explorer, and then go to the MinGW Windows 64. And you see there is a bat file here, right? So if we open it, it's just a shell command which does basically appends the bin directory of the MinGW64 B to the path in environment variable, and then opens up the CMD. So when we run this, the G++ compiler is now set to so GCC hyphen version. Now it sets to MinGW 64-bit, right? So this is not Cygwin anymore. This is MinGW because the bin directory of the MinGW Windows 64 is appended to the path, right? And then if I cd into this debug folder, let's see if we can still run make all. And obviously it's not going to work because first of all the JNI Edge paths in the make file they were absolute path and it just couldn't find them, JNI header. So we can manually go and try to basically edit this. So where is that JNI header? So let's look at the source. No, and then objects, make. No, and it's in the SRC where it tells the compiler how to compile, and you see it says GCC C++ compiler, and then I library Java virtual machine JDK 1.8 JDK. So obviously we have to change this. This is the include, and then this is the machine dependent include. So we have to change these. And then what we can do, we can quickly go and try to change this. So let's open up a file explorer, and then let's go to this PC, and then Windows, and then program files, Java, and then let's say JDK include. Okay, so the first one is the include one, so we can change this. The second one is the machine dependent one. On Windows it's Win32. And then we also put these in double quotes because of the spaces and the other stuff. So it's best to put them in a double quote. And now I'm going to add also the machine dependent folder. Okay, and everything else looks good. So so let's see. So if I run make all again, it's compiling and it's generating a dynamic library. So the makefile was successful, but then the problem here is that obviously one problem here is that let's see, debug, it generates that, and then if there was an error, so for generating a dynamic library, undefined reference to win main, so it wasn't really able to generate a dynamic library. And that's the main problem with trying to use the makefile system from one platform to another. So I think the best approach here is to use again the Eclipse CDT and import this project. So I'm going to go to desktop, test make, and then copy and paste this clean project. So it just has the source code, and we can even basically delete this debug folder, but for now I'm going to keep it. So going to CDT, let's go to the C++ perspective in Eclipse, and then let's import a project, and it asks us what is the project, and this project is an existing code as makefile project, right? So we are going to select this, and then what is the project name? Let's just quickly search for it, Maven native C, and it automatically, so let's also select MinGW GCC and then finish, and it automatically so everything looks fine. We included our project, so we can also delete this debug folder. We don't really need this because Eclipse will generate it for us, but obviously the includes are not correct because these are not MinGW. So what we need, again, we discussed this in the previous lectures, we go to this PC and we go to the home folder or root of the MinGW Windows 64, and the root is where the bin is. So this is our root, and then we right click, properties, and then C++ build, environment variables, and change the home environment variable for the compiler, and this should fix our includes. Yes. And then if I run this now, let's also give it some configurations. So we have to go to the settings, and then a few things that we need to obviously check here is compiler, and then let's manage the configurations. That's fine, default is fine, and then dialect, let's set it to C++ for 11 or 14. Let's select 14, and then the includes, so we have to manually go ahead and include the basically the JDK, JNI. So include okay, include paths. So go to the program files, Java, and then JDK, include, this is the JNI, and then the machine dependent one is inside the Win32. Okay, and then the build artifact, we want to create a basically a shared library, which is DLL. Basically the extension is DLL. And we don't need to specify any lib at the beginning. All right. So you see these two folders are not labeled as source folders. So if I run this, nothing probably going to happen. So what I'm going to do, I'm going to right click on the headers folder, and then new, and then source folder, and then I'm going to browse and select the header folder as a source folder, and then also for the src folder. So new source folder, and then browse src. Now the compiler looks into these two. So let's see if I can build this. And the build was finished. I was able, and as you can see at the moment, let's look at this default one, and no makefile was generated. That's because let's see, if we go to our build, we have this internal builder selected. If we look at our toolchain CDT internal builder, we can select the GNU make builder, apply, and close. So if I delete this folder, basically clean up, and then run the project again, make all, and then now you see that we have this makefile. So if you want to distribute, it's better to have this makefile so that others on the same platform can just easily run the make command and be able to generate the dynamic libraries. And again, we have the old make native _c DLL in this case, and then the clean target, and we have our dynamic library. All right, now let's copy this, and then maybe we just let's see, I am going to go to my shared folder, desktop, and then Maven native here, and then in the target folder, or maybe somewhere just in the Maven native, I'm going to copy and paste it, and then go to Mac, right? So here, back to Java. If I refresh this now, I have this. So in the resources, what I already had this once before, but let's delete this. Now I created the dynamic library in Windows, and then I can put it inside my resources. Now I have a dynamic library for Mac OS and also a dynamic library for Windows. So in the test native, let's what we can do right now, let's clean the Maven project. Okay, the target folder is now empty. If I run this still works, but we have to basically build it again. Okay, let's see if we can run this. Yes, this works. And now, right now, we're loading the dynamic library using native utils for macOS. But how do we, so if we package it right now, it's not going to work on Windows because we are not still loading this dynamic library for Windows. So how do we make our Java project, Maven project, the artifact, the jar file, to work both on Windows and Mac after generating the dynamic libraries for each platform? We need to check which platform the user is using, right? So how do we do that? Let's say OS string OS, we say system dot get property, and then OS dot name, and then we set it to lowercase, right? And then after that, what we're going to do, we're going to check the name of the OS. Obviously, we should also check the check the architecture, 32-bit versus 64-bit, but here I'm not going to do that because both my platforms are 64-bit. And then what we're going to say is that if OS contains let's say Mac, then it's a Mac platform. Then we say native utils load library from jar and load the dynamic library for Mac OS. Elif or basically else OS contains Win, it's a Windows, and then we are going to basically load the dynamic library for Windows. Copy, paste, and then the name of the dynamic library is Maven _native _c DLL. And again, we keep the full name when we use native utils. Else if OS contains Win, okay, and then this one. All right, now we can load both Windows and Mac. All right, so let's try to package this. Run as Maven build and then package. Build was successful. Let's refresh. And then we have our jar file. And if I go to the CPP and look at the jar file, look the inside, right now we only have let's see, we only have one dynamic library, so maybe let's clean this. Run Maven build clean. In the resources we have both of these, and then run build compile. Okay, and then let's open this folder and then look at this project. In the target classes, we have both the dynamic library for Mac and DLL. So let's run the package again. Package. Okay, so now let's refresh and then target Maven. I'm not seeing the the DLL file in the jar, so let's have a look. So let's unzip it. Yeah, we have both the dynamic library and then the DLL in the jar file. So this jar file is now multi-platform, which means it should be able to work on a Mac OS and a 64-bit Windows JVM. So let's test it. Let's go back to Windows and let's go to our desktop, and then let's go to Maven native, and then in the target we have our jar file. Let's copy and paste it on the desktop, and then let's go to our Eclipse, go to the Java project, go to Java perspective, and maybe create a new Java project, test Maven native, and then I'm going to create a new folder. Let's call this lib, and then I am going to copy and paste this jar. Okay, and then I'm going to add it to the build path. Build path, add to build path, and then we have both dynamic library and the DLL. Now hopefully if I run this test Maven JNI, this should work and it should be able to correctly load this one, DLL one. So let's run this. And now it works fine. So we took our jar file, the artifact of our Maven project, and made it multi-platform. In order to do that, we have to recompile the C++ project that was implementing those native methods both in Windows and Mac to separately generate the dynamic libraries for these platforms, and then we package them, both of them in the single jar file. And then based on the checkings that we do on the OS, and obviously we should also check the architecture, 32-bit versus 64-bit. But here I just check the name of the OS from system properties of the Java JVM, and then based on that I loaded the correct version of the dynamic library into memory. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.